Hi children, welcome to today's digital class. Children, I think you are eagerly waiting for the digital class of 9th class mathematics. Then why to wait? Let us start. Before getting into that, let me introduce you my friend Mr. Dos. Please see, he is wishing you all hi. Now, Dos, what you are going to show me? Which chapter we are going to discuss of 9th class maths? Oh, it is chapter 3. What is the name of it? The elements of geometry, right. Now, what you are going to discuss in this? This is a temple, beautiful temple, Charminar, oh, Eiffel Tower, wonders of the world, pyramids, watchtower, a building. This is a Egnikun. Now, what is the relation between the geometry and these all structures? Children, when you want to construct such kind of structures, buildings or pyramids or the monuments, we need certain basic things which are required for us to construct them. And what are required for it? And who are the people supported it? Let us just check it. See, let us go into the history of the geometry, where this geometry has evolved. What is geometry? Who discovered geometry? What are its fundamentals? That means basic things which are required for the geometry. Let us just check it. Now, see here, the branch of mathematics concerned with the shape of individual objects, spatial relationships among various objects and the properties of surrounding space is known as geometry. That means, it is a live thing which we are related to our daily activities, whatever we have, we will be able to relate it to the geometry. Is it right? Now, the word geometry is said to be derived from the Greek, but what does it mean? Let us just see. In Greek, geo means the earth, and actually they feel that earth is flat, and they discuss that the things on the flat things, but later on they have observed that earth is not flat, and now geo means we think only the earth. Metrion means measurement. So, on the whole, geometry means it is the measurement or the concept of measuring the earthly things, right. Now, let us check who has started this. Ancient people had begun to devise mathematical rules and techniques useful for surveying land areas, constructing buildings and measuring the storage containers, etc. That means, they have used the mathematical rules and concepts for their daily needs, you can say, and sometimes you can say even the rulers also have taken the help of mathematics in their kingdoms, you can say. Now, the beginning of the geometry can be traced to the early people who discovered obtuse angle triangles in the ancient Indus Valley and Babylonia around 2500 BC. Now, when we talk about India, we always speak about Indus Valley. Indus Valley is none other than the Harappan Mohenjo-daro civilization. Let us have how the constructions were existing there. Please see, you are able to see a perfect matched geometrical structures. You are able to see how the buildings are built in triangular shapes, in rectangular shapes. You see the entrance, how it is built very meticulously with all the geometrical figures, you can see. Now, there are many philosophers who contributed their part to the geometry. That means, those days the people, they used to do the researches and they used to come to the conclusion after many examplers, and with that examples they were able to give us the clarification that what is what and what a rule can be. And now, let us see the people, those who have tried to give us the explanation. Let us start with the Indian. You know Bauddhayana. Bauddhayana has proposed Sulava Sutras. In fact, it is said to be the Pythagoras theorem itself, but it has been proposed even before the Pythagoras. This is one of the a picture which has been just felt that this might be the picture of the Bauddhayana, and Bauddhayana is said to be existing 8th century BC before Pythagoras. Now, he has given a very clear description about the Pythagoras theorem in his what you call the sloka, you can say. Now, let us go to the next person, Thales theorem. Thales is the person who has given us the very beautiful theorem which is called as the basic proportionality theorem, which we use in triangles, right. Now, he belongs to Miletus, which is present days Turkey, and he belongs to the 6th century BC, followed by the different philosophers. Now, let us go to the next one, who is Pythagoras. Pythagoras theorem by Pythagoras of Samos. He is also one of the eminent philosopher who has given us the lot of proofs for the geometry, and one of the prominent proof of him is Pythagoras theorem. Isn't he also belongs to the 6th century, but it is end of the 6th century BC. Then we have Euclid of Alexandria. He is said to be lived in the 4th century BC. You can see the hierarchy here, where in that hierarchy you can see the different people who are lived here, and what is the stage where Euclids lie. You can see from down you have the Pythagoras and so on, Plato, and then Aristotle, then Euclid, Archimedes, etc. You can see them. That means, here Euclid is the one of the person who has proposed the different types of rules to the geometry, but the problem what is that is, here he has given us a very keen and clear explanation, that is a proof manner to the geometry here. He wrote a book on geometry, that is known as the Elements, which is of 13 volumes. You can see the picture, original picture of that one, which has been printed here. This is the Elements of Geometry written by the Euclid, and 13 volumes means 13 books you can say here, and each and every book will give us the explanations about the rules and properties of the structures of the geometry. Now, since he is the person who gave us the proof, we call Euclid as the father of geometry. So, Euclid is known as father of geometry. What does Euclid do? Euclid had given deductive proof for the geometrical concepts. Euclid created the first system of thought based on fundamental definitions, axioms, propositions, and rules of interference or logic. Now, what is it? It is a point. It is a straight line. It is a straight line which is parallel to the previous one. It is a line which is intersecting both the previous lines. It is an angle, perpendicular, a triangle, a trapezium, a parallelogram, a circle. If you see all of them, these are said to be the basics for the construction of the geometry, you can see. Now, how these are being defined by Euclid, let us check in the further. What is it? Brick. Normally, a brick is said to be in a solid, isn't it, shape. A solid will have length, a solid will have breadth, a solid has the height. That means, it has 3 dimensions, length, breadth and height. Suppose, if I remove any one of the dimension, let me remove the height. If I remove the height for this brick, what is remain here? It is just like a plane which is looking like a rectangle, is it right? Now, for this plane, if I remove one of the dimensions which has 2 dimensions, that is length and breadth, out of those 2 dimensions, if I remove one of the dimension, let me remove the breadth, what happens? Let me see. I am left with only length, that is looking like a straight line, is it right? Even if this length is also reduced, or you can say it has been removed, almost all we can say negligible position you will be able to see, that is like a point. Now, you have observed that a brick is a solid with 3 dimensions. It has length, breadth and height. A solid loses height, then it remains as a plane or a surface which is having only length and breadth. If a plane loses breadth, then it remains as a line. If a line loses its length, then it remains as a point. Now, when a brick it is having 3 dimensions, that is length, breadth and height, it is called as a solid. When a solid is losing the height, that is 1 dimension, it became a plane. When a plane has lost more dimension, it became a line. When line also lost its dimension, that means almost all the length is negligible, you can say it is a point. Now, see here, a 3D became 2D, 2D became 1D, is that right? And here we cannot give the clarification regarding the point, because point is said to be not having any kind of dimensions. Let us discuss about it. From book 1, some of the Euclid's listed definitions, that means we cannot discuss all of them, but let us have some of them here. A point is that which has no part, already we have just now discussed. When solid became plane, plane became line, line became point, like that. A line is a breadthless length. The ends of a line are points. A straight line is a line which lies evenly with the points on itself. The rest of the surfaces are lines, surface or surfaces you can say. Now, a surface is that which has length and breadth only, that means it is not possessing any kind of height, that is what he meant to say here. Now, let us see some more things. As per Euclid, a point, a line and a plane are undefined terms. A triangle, a square, etc. are defined terms as per him. The assumption of the geometrical the assumptions of geometrical properties are divided into 2 types. Here he has classified them into 2 things. One is based on the proof and based on the without proofs. Now, one is axioms, the other one is theorems. Let us discuss what are these axioms and theorems. So, as per Euclid, the assumptions which are self evident, which do not require proof, are known as axioms. Similarly, the assumptions which can be proved logically are known as theorems. That means, both are seems to be true, both are true in facts, but the thing is that is axioms we cannot give any clear proofs, but theorems we can give a systematic and step by step proof for them, isn't it? So, now we have to discuss some of the Euclid's axioms. We will see here. Things which are equal to the same things are equal to one another. That means, if I say there is a value A which is equal to B and B is equal to C, then automatically we can say that A is also equal to C. So, in this we can say things which are equal to same things are equal to one another. If equals are added to equals, then the wholes are equally. For example, let us just discuss here. There is an equality, let me say 5 is equal to 5. If I add 2 on left side and 2 on right side, then the value on left side 2 plus 5 becomes 7 and on right side 5 plus 2 becomes 7. That means, both are equal again. That means, when you are adding equals to the equals, then the wholes are equal again. This is what he proposes. Things which coincide with one another are equal to one another. Suppose you take 2 bangles of same size and you put one over the other, you will observe that both are coinciding with each other. That means, you can say that things which are coinciding with each other, they are said to be equal. So, once again I read this, things which coincide with one another are equal to one another, right. We will see some of the postulates of the Euclids, but we have very prominent postulates of the Euclids. There are majorly 5. Let us just discuss about them. Now, what is a postulate? A postulate is a statement that acts as a starting point for a theory. Since a postulate is a starting point, it cannot be proven using previous results. That means, whenever you are saying it is the basic for it, a basic cannot have any chance to be proved with the previous results or previous concepts. That is the reason we say a postulate is always a starting, and here a postulate should be self evident. That means, it must be true in all the cases. Now, Euclid's postulates. Postulate 1. There is a unique line that passes through the given two distinct points. That means, in other words, you can say that one and only one line can pass through two different points in the plane. Let us see the postulate 2. A line segment can be extended on either side to form a straight line. Actually, the meaning of this one is that he mean to say that segment means part. So, line segment means it is a part of a straight line. So, what he is saying that is a line segment is going to end with 2 points on either side. If you do not have those end points and you try to extend them, it is looking like a straight line. You mean to say that, in other words, line segment is a part of a straight line. Now, postulate 3. We can describe a circle with any center and radius. That means, here he is explaining us, if any point is given and a fixed radius is given, you can draw a circle, he mean to say that. And for this, so that we can construct a circle with a fixed center and fixed radius, right. Now, postulate 4. All right angles are equal to one another. Here the meaning of all right angles means, if you find a right angle at one place and right angle at another place, or one figure and with the other figure, in that cases also we can say that the measure of right angle here and measure of right angle there, both are equal. That is what he mean to say. All right angles are equal to one another. The fifth one we are going to discuss, that is postulate 5. It is one of the prominent postulate of the Euclid. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together is less than two right angles, then the two straight lines, if produced infinitely, meet on that side on which the sum of the angles is less than two right angles. Now, let us see how it is happening and what is the reason here he has proposed this one. Let us see the diagram here. Are you able to see the diagram? There are two straight lines and you are able to see there are two angles, one is x degrees and other one is y degrees. Sum of those two angles, that is which are interior, x plus y, which is less than 180 degrees, means I have to see that which side they are. For me now they are on right side. That means, I have to expect that these two straight lines may intersect. Let us try to produce the first one. Yes, it has been extended, second one also extended. You please see what happened here. The two straight lines were intersecting on the side where the sum of the angles is less than 180 degrees. Now, let us go to the another concept called as conjectures. The statements which neither proved nor disproved are called conjectures. That means, sometimes we cannot give the clarification whether it is true or whether it is not true, whether to prove or not. So, in that cases you can say they are hypothesis or just you can say conjectures here in this context. The conjecture that is proved to be true is called a theorem. The conjecture that is proved to be true is called a theorem. That means, the statement which is proved, you can say it is a leading to the theorem. We have discussed all this time about the Euclidean concepts and Euclidean rules and properties for this geometry. Among all the Euclidean postulates, fifth postulate is independent and prominent, and you can see that there are the three mathematicians Carl Friedrich Gauss, Lobachevsky and Bolyai have identified a geometry where fifth postulate is not valid, which contradicts it. See, as per him, what he is saying, if with that the sum of the angles is less than 180 degrees means they must intersect. So, in other words, that fifth postulate says that is sum of the interior angles of a triangle is 180 degrees or two right angles. So, this is going to be invalid. Why and how and where? Let us check it. Let us take a ball whose surface is a curve and let us draw a triangle on it to check the sum of its interior angles. This is a ball, you are able to see, is it right? And now I have drawn a triangle on it. There is a triangle drawn on the surface of a ball. Now I am able to draw the angles, you are able to see the angles, three angles on it. There are three angles which are drawn for the triangle, which are interior of the triangle. Now what can you say the sum of these angles? What is the sum of the three interior angles of this triangle which is drawn on the surface of a ball? Is it equal to two right angles? No. Thus, it is a surface where Euclid's postulate is not valid. Here we have observed that the sum of the angles of the triangle is not equal to two right angles. That means, Euclid's postulate is not valid. So, we can say thus it is a surface where Euclid's postulate is not valid. If it is not valid means what you can say? Therefore, the geometry in which the postulates of Euclid are not valid is known as non-Euclidean geometry. Now, let us have a recap. In this chapter, we inquired of the origin of geometry, which led us to the ancient traces. That means, we try to identify or we try to understand where and who started the geometry, but it has taken us to the ancient traces discovered geometry. But we can see that there are many philosophers who propose their theories in support of geometry. We have seen Euclid's definition, Euclid's postulates, axioms, theorems, conjectures, and even we have discussed about non-Euclidean geometry. Children, try to solve the exercise problems of your textbook. So, for you small assignment. The first question, if triangle ABC is isosceles and AB is not equal to BC, that means side AB is not equal to side BC, can half of side AB is equal to half of side AC? Please state the reason for it. Second question, in quadrilateral PQRS, if angle P is equal to angle R and angle Q is equal to angle S, is angle P plus angle S is equal to angle R plus angle Q? Please give the reason for it. Now, third question, how many faces a cube will have and what are the shapes of its faces? The question number 4. Observe the figure below. If angle 1 is equal to angle 2 and angle 2 is equal to angle 3, angle 3 is equal to angle 4, then write the relationship between angle 1 and angle 4. Please see the figure and tell me. Children, apart from these questions, I expect you can try to solve the examples and exercise problems of this chapter from your 9th class mathematics textbook. I hope you understood, and whatever it is there, you can go through the textbook and ask the doubts to your concerned teachers. Children, in today's class, we have discussed about the concepts which are required for the geometry, isn't it? That the chapter name is the elements of geometry, and we have discussed various concepts, various topics of it, like axioms, postulates, Euclid and other philosophers who have contributed their part to the geometry, isn't it? Now, you can go through the textbook, the examples which are there, and at the same time you try your level best to solve the problems which are given in the textbook in a exercise. I hope you will be trying yourself. Thank you children, that is all for today.